Good afternoon, everybody. My name is Daniel John Mitchell. I'm the director of the Center for Historical Research at the Science History Institute. I'd like to welcome you to this, our fourth lecture in the Science Incorporated Constructing the Natures of American Modernization series, where we look at the social, cultural, and political entanglements of science and technology in 19th and 20th century America and their reciprocal impacts on the construction of scientific knowledge. Now, before I move to introduce our speaker today, Sarah Reynolds of the University of Indianapolis, let me go through a couple of practical things. Firstly, I just want to make sure that you can see me and have the best possible view to see our speaker. So the best way to do that is to take your mouse and scroll to the top of your screen where it says View Everyone, and you just select who's talking. And then when I hand over to Sarah, obviously you'll see her and her slides automatically. Now, the format of today's lecture, like all of our lectures in the Lunchtime lecture series, is a talk of about 40 minutes or so, followed by 15 minutes of questions. So we found that the smoothest way for you to ask a question is to use the chat function. So again, if you go to the top right of your screen, you'll see there a little speech bubble. If you click on that, you can open the chat window, and then you can type a question into the box. Now, it's very important, especially today, we're having some power outages in Philadelphia, to send your question to organizers only. So at the moment, it will say on your screen at the bottom, send to everyone. If you just click on everyone, which is the drop down, and select organizers only, we have a cunning way of transmitting the questions to me if, unfortunately, I end up dropping off the call. So let me now introduce our speaker, Sarah Reynolds. She is an assistant professor in physics and earth space science at the University of Indianapolis. She holds a PhD in physics from the University of Kansas and is finishing up her second PhD in the history and philosophy of science from Indiana University on the history of educational uses of experiments, particularly in the development of laboratory-based instruction in the 19th century United States. Now, her main teaching focus is on developing scientific skills in future educators. So she brings a really novel perspective to her historical research through her day-to-day teaching practice. Sarah joined us at the Science History Institute as a short-term research fellow in 2018 to 19, so very recently, with the intention of looking particularly at student notebooks of classes in laboratory chemistry. Now, Sarah, I'm particularly excited, as I already discussed with you, about your talk today, because you know that I've been carrying out my own research on exactly this kind of topic, but with a European, a British, and French focus, also in the 19th century. So it'd be really interesting to see the ways in which our work syncs up. So Sarah, let me hand over to you, and welcome.
Thank you, Daniel. And I'd like to thank the Science History Institute for hosting this series and inviting me to speak. And of course, also thank you to the Institute for welcoming me to do research there. I was there last summer for a couple of months. It was really nice to get to spend a summer in Philadelphia, and the people that assisted me in the collections, I really appreciated the chance to get to know, as well as how helpful they were to me and my research. Philadelphia was a great place to be for a project like this, and I think you'll see some of why it's so relevant to looking at the history of this in the United States. And I also do want to thank also Indiana University, which has provided some of the funding for my dissertation over the years, as well as archivists at the Library of Congress and Rensselaer Polytechnic Institute, which also have materials that contributed to this talk. So today, sorry, let me get to the right window to change that slide. Today I'm going to be talking about the history of the lab class and the pedagogical shift to having students sort of take their own role in the laboratory and carrying out scientific experiments themselves as part of their studies. Now, of course, today these classes are an incredibly common part of high school and college experience. as well as something that has become part of elementary schools, even in the way that we do inquiry-based learning and encourage active participation and active investigation at lower grade levels. And probably many of you, if not most of you, have taken a science lab class at some point or in some form or another throughout your careers. And you may or may not have enjoyed that experience. It's always a little, there's sometimes different responses there from the college students. But even with that, most scientists and educators today would consider this an essential and frankly a rather obvious method of formal science education, that students would learn to carry out experiments themselves, and that in doing so, they would be recreating standard experimental practices and results. They'd be developing a variety of practical skills, and they'd be enhancing their understanding of scientific knowledge and the way that it's founded in research. Right now, of course, across the country, this is one of the particular educational challenges in figuring out how you adapt the lab class with all this emphasis on activity and interaction to the new realities of teaching in the case of the novel coronavirus. And so figuring out how to carry this out virtually at a distance is something a lot of educators are dealing with right now. What we're going to see is that when we go back to the 1800s, formalizing the laboratory as an educational space and as a type of instruction was not always such an obvious or widespread practice. And I think when we look at that, we start to see some ways in which the development of laboratory classes reflects some of the history of how they emerged, right? And so this is another practice where the particular form that we end up with is shaped by the history. There's a few basic historical questions that I think we might wonder about in terms of what happened before the laboratory class. How exactly was science taught? How did scientists learn to conduct experiments? And when and how did scientists make the transition to becoming practitioners before these kinds of classes existed? And so we'll get some glimpses into some of that history, particularly in the US context. Now, a couple of weeks ago, Ben Gross had a great slide at the beginning of his talk that was sort of this talk is rated history slide. And so I wanted to kind of add my own in, my sort of warning slide, which is that terms in history may be stranger than they appear. And part of this is that, you know, even though we're going back to the 1800s in the United States, it's not a long, long time ago in a galaxy far, far away. And yet, even just going back then, we find that actually some common terms can have really different meanings. And so when we see people in the 19th century using terms like experiment, science, laboratory, and method, even though those are really familiar terms, we have to look carefully at the texts that they're writing and the way that they're talking about these in order to really understand what they mean. And I'll try to highlight as I go through the talk some of the notable differences that I've encountered in some of those terms. So the first place we're going to start is actually in the 1890s, and then we're going to kind of work backwards. But I want to start off in the 1890s because this is where the 19th century ends up, and it's the point that really leads in a strong and very influential way into some of the rapid and widespread developments of the early 20th century and the way that science becomes an important part of progressive education movements at that time. So in order to sort of see how that gets set up, we're going to start in the 1890s. And in the 1890s, you already have this strong growth and promotion of educational laboratories, where they're placing quite a bit of emphasis on the role of the laboratory in education. I think we're getting a little feedback. And so here, for instance, is one of the quotes that sort of shows this by James Lewis Howe, a professor at Central College in Kentucky. Later on, I think he's at Washington and Lee University and is kind of known for his work there. where he calls laboratory work the sine qua non of scientific study. He's sort of saying this is the one essential thing that you have to have in order to study science. And so you can see he's saying that at the present day, it's so far acknowledged that in none of our colleges and few of our better high schools and academies would the instructors think for an instant of trying to teach certain sciences without the laboratory. So the laboratory has become essential by this point to the way that you teach science. And you find also these very strong statements about why exactly the laboratory is so essential to education as they see it, and actually is considered to be part of sort of the larger purpose of education. And one great example of this is by Henry Augustus Rowland, one of the founding physics professors at Johns Hopkins. And in the 1880s, he says this, that to produce men of action, they must be trained in action. And then basically saying that that happens by entering the laboratory and standing face to face with nature. That's where students learn to test their knowledge constantly and see for themselves the sad results of vague speculation. They must learn by direct experiment that there is such a thing in the world as truth, and their own mind is most liable to error. They must try experiment after experiment and work problem after problem until they become men of action and not of theory. And this is part of that, this is the educational philosophy that goes along with this new emphasis on the laboratory, that it's in the laboratory that you become active and responsible for your own learning. And that's part of why they promote it. Another really great pithy quote, one of my favorites, is a statement from Charles S. Minot at Harvard Medical School in 1899, where he says, "Knowledge lives in the laboratory. When it's dead, we bury it decently in a book." So again, that emphasis on activity. And one of the things that becomes very interesting in this period with this focus on the laboratory is that when you look back early, in the early discussions of the laboratory is basically a workspace for a chemist. It's a place for preparing chemicals, often for pharmaceutical purposes. And so that's really the origins of the laboratory as a place. But by this point, you've seen the laboratory sort of start to spread and be applied as a workspace for a variety of fields and different disciplines of science. But you also, in the focus on the laboratory, what they'll start talking about as the laboratory method of teaching or the laboratory method of instruction, you find that the laboratory is now not just a place in which these things happen, it's actually an approach to education itself. And so the laboratory sort of transcends the place when they began talking about it in this way. And you'll even find discussions of the laboratory method for teaching mathematics or for teaching grammar or teaching foreign language, because it all has this kind of commonality of being a method by which students are sort of learning through direct experience and starting off through investigation and then learning how to sort of build their knowledge out of that. And so the laboratory has moved beyond just being a location to being an entire way of sort of approaching learning itself. So part of this, in this growth that you see at the end of the century, part of it is reflected in actual financial investment in buildings and equipment. There's a lot of construction of university lab facilities during this period, and a lot of that construction is actually documented in journal publications at the time. They will publish an account of the new laboratory with maps of how it's laid out, and it's set up, it's being set up in a really systematic fashion to facilitate these different classes. Now, there's still some debate going on about what's the most effective and efficient way to teach a laboratory class, how exactly it should be run. and how the professor should interact with students and all of that. But there is this like sort of like large scale movement to that, and that pedagogical debate is really happening in sort of a large fashion, right? Because it's valued as an approach, it's being propagated, it's being spread, and so you have that kind of discourse going on. So one example of one of these buildings is the Laboratory for the Case School of Applied Science, built in Cleveland, Ohio. This is what would become part of Case Western Reserve University later on. And it's erected in 1892, and at the opening sort of ceremonies for it, Charles Maybury, professor there, is giving a talk about what are the purposes of the chemical laboratory for modern education. And he's giving the same sort of argument we saw before, where he's saying it's an essential part of both liberal education for the everyday person and for people that want to train to be scientists in the future. And so he's got the basic argument. He's saying this is, chemical training is valuable for people from a variety of fields. The laboratory is an essential part of that. And that part is sort of right in line of everything else we see at this time. But what I want to show is that as they're talking about this, they're also starting to develop a certain history that they will recount of how exactly this transition happened. And Maybury's account is fairly representative of this as well, where he says it's only within a comparatively recent period that the chemical laboratory has attained the prominent position it now occupies in colleges and schools of science. So this is a recent development, and they'll sometimes talk about it as like a transformation or a revolution. And he goes on to say that indeed, in its present development, with facilities for practical study in organic and inorganic chemistry, both elementary and advanced, 30 years ago, there was not a single laboratory in this country and few elsewhere. Probably the earliest attempt in this country to give systematic laboratory instruction to classes of any magnitude was made in 1865 at the Massachusetts Institute of Technology. And like many people writing history, where Maybury gets into problems is in sort of the stronger parts of this statement. Now, he has a few caveats about exactly what he has in mind in talking about this laboratory, but he is saying, this 30 years ago, there was not a single laboratory in this country, which is pretty strong. And then he's pointing specifically to these classes in 1865. And that's the point at which Maybury gets challenged. His speech is published in the journal Science, Journal of the American Association for the Advancement of Science. And it gets challenged in a letter to the editor just a couple months later by William Mason, professor at Rensselaer Polytechnic, who writes in and says, "Surely Professor Maybury is in error upon this point, as such instruction had been given to the students of RPI for many years previous to the date quoted. Our present laboratory, which is very complete and accommodates 76 students at a time in analytical chemistry, was built in 1862 and replaced one that was destroyed by fire." Yes. Now, Mason goes on to quote recent correspondence from James Hall, a prominent New York geologist, who had been a student and an instructor at Rensselaer in the 1830s and was very familiar with that institution. And James Hall says, yeah, in the 1830s, there were already laboratories fitted up for giving systematic instruction in chemistry, and each student of the class was required to do laboratory work to prepare himself, his materials, and apparatus, and give an extemporaneous lecture illustrated by experiments. Okay, so this is saying, we were already, we had systematic instruction, we had students carrying out experiments at RPI earlier. Now, this exchange is just a little bit of what I think is a larger sort of question of looking for a more elaborate history of what happens with laboratories in American higher education during this 19th century. And part of this is that the 19th century in American higher education is itself a time of dramatic change and often tumultuous growth. There's a huge proliferation in institutions, only a fraction of which actually survive, and many of which end up going through several iterations and then coalescing into the institutions that we're more familiar with today. But it's a very dynamic sort of situation. And science plays a really important role as a lot of that is going on in these sort of debates about what exactly higher education is going to be and who it's going to be for. And so when we look at this history that's usually told of laboratory instruction starting in the United States in the 1860s and 1870s, the same sort of story that Maybury was recounting in the 1890s, and which a lot of times is sort of propagated into later historiography, we can look back and start to wonder, well, what was going on before then? And were there really no laboratories giving instruction prior to this? So just to fill in a little bit of that history, and then we're going to look at it in a little more detail. In 1804 is when Yale begins undergraduate chemistry classes. They're actually about the second place in the United States to do so. The College of New Jersey, which would become Princeton, actually does this a little bit earlier, but without quite as much long-lasting success. And so 1804, that's what's happening at Yale. They're starting to teach chemistry to undergraduates, although it doesn't have a strong laboratory class kind of component. In 1824 is when we have the Rensselaer School, later RPI, coming on the scene. And when you look at the founding documents of the Rensselaer School, you see that it's actually written into those documents that Rensselaer, that part of the method there would be that students would lecture and experiment by turns, that students would conduct their own experiments in chemistry, and also their own sort of field work and investigations in geology and botany and other sort of sciences. In 1847, we have the founding of the scientific schools at Yale and Harvard. And I mention these because both of these scientific schools were really all about having practical instruction for people that wanted to go into science in a more professional manner. That was a strong portion of what these scientific schools were trying to do. At Yale, it actually has kind of an earlier history feeding back into that tradition of science that develops in the early century, where they had been doing sort of informal aspects of this education, and then it sort of gets formalized into the scientific school in 1847. But at both of those schools, you find these efforts. And one of the reasons those also are significant is because a lot of the people that are doing these, starting these classes later in the century, in the 1860s and 1870s, a great number of them you actually find had connections, had training, or were doing initial instruction in the scientific schools. So there's ways that they come out of that tradition in a really important manner. So I'm going to spend the rest of the talk looking at a few particular examples of a couple American scientists and educators that I think sort of help us get a little glimpse into how teaching and learning science through experiments worked in the earlier parts of the century, and what was happening before those lab classes really emerged. And so I've put them here, not with their lifespans, but with the times that they were sort of active as educators in science in the US. And so we're going to start off with Benjamin Silliman, who arrives in Philadelphia in 1802. And this is actually a little map from the Science History Institute. I think the archivist put it together several years ago. And it's of Priestley's Philadelphia. And if you get the full version, it actually nicely has marked out some of the different places, a lot of which are places that were sort of relevant to chemistry in Philadelphia in the early 1800s, at the time when Joseph Priestley was living near there and coming to town. And the nice thing is that This is also the same sort of time that Silliman shows up to study chemistry in Philadelphia, so a lot of the places kind of overlap. I've put a little star here of where the Science History Institute is, but then Silliman actually stays and does some chemical experiments at a boarding house, which he talks about as being down here at Walnut and Dock. So it's really only about a block or two from the Science History Institute if you ever get a chance to kind of explore around there. I don't think the boarding house building is still standing, but when I was there, I kind of walked down and at least stood around on the sidewalk next to somewhere around where Silliman was experimenting back in the day. So Benjamin Silliman arrives to Philadelphia as a young man who has just been recently sort of recruited and assigned the task of teaching chemistry, despite the fact he has almost no background in the science whatsoever, by the president of Yale. I won't go into sort of the institutional drama surrounding why he picked Silliman as opposed to other people that might have had more actual background for something like this. But he chooses Silliman. He says, hey, chemistry, it's going to be this up and coming thing. You have a chance to sort of get in at the ground level and really make a career for yourself. And so he sort of sells a young Silliman on this as a career possibility. And Silliman, when he gets this task, sort of inquires around and gets the textbooks, right? He gets some common books on chemistry and he starts studying through them. But he quickly realizes that in order to really make any progress in chemistry, you have to see and perform experiments and become familiar with many substances. And so where do you go to do this in the United States at this time? It's Philadelphia. And so he is sent on a funded trip by Yale to Philadelphia for 2 sort of winters in a row in order to study chemistry there. Philadelphia at this time is teaching chemistry mostly for the purposes of medical physicians. This is kind of the main reason chemistry is being taught in higher education at the time, is for physicians with sort of a pharmaceutical kind of purpose. Even though there are pushes towards more interest in chemistry for also looking at mineralogical analysis and agricultural advances and things like that. And what you start to find is that even though the chemistry classes in Philadelphia are ostensibly for physicians, they are being sort of marketed and often come to by people that are not physicians for these other sort of purposes and their own interests. And you can see that in this advertisement for Woodhouse's lectures on chemistry, which is actually what Silliman comes to Philadelphia to attend. So James Woodhouse is conducting these courses, like I said, mostly for physicians, but other people were welcome. And you'll notice here that they're emphasizing that Woodhouse possesses a complete chemical apparatus, and during the course, several thousand brilliant experiments are exhibited. And this is the way that experimentation is really being used in chemistry and in science education at the time. It's used as a method of sort of giving a proof, giving a demonstration of something that you are learning. It's meant to be sort of fascinating and engaging, but also sort of an instructional reinforcement done by the professor as sort of the expert in the room, although it'll often be carried out by an assistant who's doing the actual work while the professor talks about it. But you might also notice that's a lot of experiments, several thousand brilliant experiments in a couple months' time. What does that actually look like, especially if these are all being done at the front of the room and not by the students themselves? And so we can get a glimpse into that by looking at another little publication by Woodhouse, which was the Young Chemist's Pocket Companion. This actually came, you could buy it along with a little kit that had chemical materials in it. And it was designed for people that were just kind of interested in chemistry and wanted to, experiment some with it. But when you look at it, you see what sort of experiments Woodhouse was probably doing in these lectures of his. And you'll notice that the experiments are brief, unique steps. They're really just little experiences, little things you can do. And in some cases, they don't even show something that happens. Sometimes they show nothing happens, and then the contrast is like you do this thing and nothing happens, but then you do this thing and something else happens, right? So this is how you end up with several thousand experiments. So you can see here, you're dipping a piece of paper stained by blue cabbage or some other vegetable blue into a wine glass containing water, and no change will be produced. Or you dip a piece of litmus paper turned red by an acid into a wine glass containing water, and no alteration will take place. And then it would be contrasted by a following experiment where you expose it to something that does cause a change. Some of them are also basic sort of recipes for something that you're trying to make. So for instance, to make alcohol of galls, you put in 1 drachmae of galls, a 2-ounce vial, and you fill it up with wine, right? So basic sort of little things that you could do. So Silliman attends Woodhouse's experiments. Experimentally illustrated lectures is really what these were. And he does not actually approve of them in a very high degree. So he says, the chemical lectures were important to me because I hadn't seen very many experiments yet. Every fact with its proof was an acquisition to me, right? So you learn the fact, you learn the principle, and then you see the proof of it through the experiment. The apparatus was humble, but it answered to exhibit some of the most important facts in the science, and our instructor delighted, although he did not excel in the performance of experiments. And this is where Silliman's critique is kind of interesting, because Silliman says, our professor had not the gift of a lucid mind, nor of high reasoning powers, nor of a fluent diction. Still, we could understand him, and I soon began to interpret phenomena for myself and to anticipate the explanations. So he's not that impressed by Woodhouse, and it's partly because Woodhouse is interested in the experiments. He's good at doing the experiments. You know, there's other accounts of Woodhouse and how he really loved experimenting, and some of the things he was doing in his own private laboratory. But for Silliman, he didn't have these sort of gravitas and exemplary qualities that Silliman expected in a professor. And if you were to contrast, for instance, what Silliman says about Woodhouse with the way that he talks about people like Timothy Dwight of Yale, who he talks about as just sort of being overwhelming and inspiring with his brilliant mind, and you know, even sort of almost intimidating when he's a young student there. But that's Silliman's ideal of what a professor should be, this sort of rhetorical exemplar who, and moral exemplar also, is a strong part of New England educational tradition at that time. And so Woodhouse doesn't quite meet those categories as far as Silliman's concerned. He likes seeing the experiments, but he really kind of thinks that that has to be combined with a greater degree of refinement and rhetorical flourish in order to make them really, really, truly educationally ideal. At the same time, we find that Silliman is actually learning to experiment more directly through sort of informal experiences in Philadelphia. And especially that's through meeting Robert Hare, who is a brewer's, also not a traditional physician. And that's part of the reason that Robert Hare actually struggles for a while to get an academic teaching position, despite being a very, very brilliant and talented experimental chemist. He doesn't have that physician sort of background and purpose. But Robert Hare is a young man. He's about Silliman's age. I think he's 1 year younger, and he's staying at the same boarding house. So the two of them basically set up in the basement. And Robert Hare has already invented at this time his oxyhydrogen blowtorch, which basically is able to heat metals to a really high degree and do interesting chemistry with that. And so he's trying to do it with some new chemical reactions to sort of set it off. and some different fuels. And so he involves Silliman in this. And so Silliman helps kind of fund it. He talks here about how he's kind of paying for the equipment, which keeps being broken. But he gets the benefit of Hare's experience with doing and constructing experiments themselves. And the thing that becomes so interesting when you look at someone like Silliman and the way that he uses experiments, even though he doesn't teach laboratory type classes, he uses the experiment in ways that really build Yale's reputation in American education broadly and in science specifically. So he publishes journals of his various trips to Europe, where part of what he's talking about is visiting various laboratories, doing experiments there, seeing experiments there, or talking about experiments there. They have sort of a failed attempt at a soda business. But what really starts to put them on the map are things like he does a chemical analysis of a fallen meteor. And this is a big deal. Everyone sees this meteor fall, and then Silliman actually manages to get a hold of a sample and do a chemical analysis that has been published in a number of papers across the country, as well as in Europe, and is kind of groundbreaking in that regard. He also is securing several valuable geological and mineralogical collections to be housed at Yale that really becomes sort of an attraction to make it sort of a research center that a lot of people come to study. He starts off as not a very good experimental lecturer, but over time he improves and starts to become very appealing. And as Yale's reputation in science grows from these other things he's doing, it also becomes a place that other places in the country start to send people to in order for them to learn how to teach science at their own colleges and universities. So you start to see this correspondence and actually like travel trips of people coming to Yale to study there briefly sometimes, but enough to get an idea how to go back and conduct and teach experimentally illustrated lectures themselves. And of course, Silliman is also well known in American science for founding the American Journal of Science, which is often known at the time as just Silliman's Journal, one of the first major American scientific journals. And a lot of this exchange in science is actually connected to sort of curating and developing the experiment for purposes of education as much as anything else, right? So there's research going on, there's exchanges about the research, but what you see Silliman doing is sort of pulling out from all of that exchange, refining, continuing to develop his courses and the connections between them and the experiments that he does at the front of the classroom as part of the course. And then his textbooks are also developed to help others carry out these same sort of courses themselves. Similarly with Robert Hare, you also see Hare kind of continuing to develop, and Hare sort of very explicitly talks about how he's developing his experimental methods, not just for research, but to make them more interesting and illustrative as something you do in education. So one of the people that comes to Yale for training, again briefly, is Amos Eaton. And Amos Eaton is actually, when he comes to Yale, he's looking for sort of a restart in his career. He'd always been interested in science, especially science for practical purposes, but he had been done his legal training and then been a land agent, and unfortunately got involved in a land deal gone horribly wrong that actually landed him in the New York State Penitentiary. When he gets out of there, he's looking for a way to sort of further his scientific studies, and he goes to Yale to start off with. Then after he gets, studied briefly at Yale, he starts kind of going around, has some brief teaching stints. This is pretty common in this, doing, short courses of lectures at various institutions and also small towns, traveling around to a variety of places in New England as an itinerant lecturer. What Eaton really is ultimately all about in his work, and you could kind of, I should have pointed this out on the last slide as well, is about making the experiment something that's accessible and useful for the everyday person, and not just a scientific expert. And so you can see here in part of his discussion from the chemical instructor, he's talking about how he's trying to present science in a manner that renders it accessible to all academies and to all other public schools. These would have included lower level schools, not just colleges and universities, where competent teachers are employed. I have even endeavored to bring down the sublime science of chemistry within the reach of the laboring agriculturalist, the industrious mechanic, and the frugal housekeeper. I've selected those experiments which can be performed with the least expense, which are most unequivocal in their application, and given directions with a particular view to materials that are within reach of the instructor. And in a letter to John Torrey, he puts this a little bit more pointedly and colloquially, where you can see him talking about, you know, how are his lectures so popular? How are they so effective? And he has this little dig at Silliman, who he views as a little too New England elite, and says Silliman would do nothing here. But I turn everything in science into common talk. I illustrate the most abstruse parts by a dish kettle, a warming pan, a bread tray, a teapot, a soap bowl, or a cheese press. And Eaton's efforts at Rensselaer, right, where he is actually involving students in conducting experiments themselves, are an outgrowth of this emphasis on practicality, and partly because he's trying to teach other people to do what he had done as an itinerant lecturer, to be able to travel around to teach the everyday person, to give these illustrated lectures, and to teach in a very practical manner. Encouraging scientific knowledge and development sort of among the populace, as well as developing their own skills as chemists, as practical chemists, as geologists, and surveyors. And so Eaton's Rensselaer plan of education is itself, it's a reform, as opposed to Silliman, who's trying to fulfill sort of an existing educational ideal. Eaton is very much emphasizing, no, I'm doing something different. This is a new approach to education. And part of that is that students are going to be directly involved in the process. Now, part of that is on the field science side. He's one of the first people also to take his students out into the field and do studies directly with them out on location and go out exploring the woods to study botany, etc. But in chemistry, this means doing hands-on experiments themselves. And basically, they're learning by being the sort of lecturers that they want to develop into. And so they don't learn by seeing experiments and hearing lectures, but by doing them themselves. And I'm going to skip ahead just a little. We can come back to this later, because I do want to get to one of Eaton's students. I will just mention that education at Rensselaer, there are some strengths to it, right? And one of the biggest strengths, I think, is that Eaton's good at making students into colleagues, into really working with them directly. The challenges tend to be the same challenges everyone's facing in American higher education at the time, which is that there's a very mixed caliber of students. There's a lot of costs, especially with scientific work. There's a lot of challenge in balancing teaching with scientific work. That's something a lot of people relate to today as well. And these are very small colleges that often depend on just a few key faculty members, sometimes even just one. And so it means they're very sensitive to disruptions, and they're very subject to sort of the whims of that particular person and the particular group of people in the community that are supporting them. So the last person I'm going to talk about briefly is Eben Horsford, who is one of the students that comes to Rensselaer, studies there. He's from Western New York. He grows up kind of doing all sorts of things out in the woods, and very active young man, learns chemistry and some science even in high school. So you can see how that's already sort of starting to become part of education more broadly. But then he gets sort of recruited to Rensselaer after working on some of the geological surveys. And so he's there as a student and sort of an assistant instructor for a year, and then becomes a professor at Albany Female Academy, where he's teaching chemistry, astronomy, and other sciences. And from the accounts of Horsford's teaching there, the reviews that are written of him, he's very compelling as a lecturer. And he does teach in this experimentally illustrated manner. So we know that he was conducting chemical experiments in front of the classroom. He was involving his students in doing some of those experiments themselves, much like he'd learned at Rensselaer. All of that said, he has a lot of enthusiasm, which is clear from sort of the reviews that are written about him. A lot of enthusiasm, a lot of passion, and he's very good at teaching. What he doesn't have is the scientific accomplishment that he needs in order to really make him impressive in a large sense. And this becomes especially a problem when Horsford falls in love, because he wants to marry Gardner, but he is not nearly qualified enough for her father to approve of him, because he doesn't seem to have a clear career path, and he doesn't have any money to speak of. And so Horsford is looking for a way to sort of quickly up his potential in the world and make some advancement. And despite the fact he's very frustrated about being sort of told, no, you can't court my daughter, he is looking for a way to get to where he can. And what's advised to him is to go and study at Liebig's laboratory in Gießen, which at this point is starting to become well known as a place for training in very practical, very research-focused chemistry, different from what's going on at Rensselaer, right? Rensselaer's having students do experiments, but not so much for the purposes of like hardcore advancement of chemical research, although maybe a little bit more for the purposes of geological study. So Horsford goes to Liebig's lab overseas, and there's some interesting tensions in kind of the way that Horsford describes his different experiences. Later on in his life, when he's talking about Rensselaer, he says, the methods pursued under the guidance of that great teacher, Liebig, were in many respects the methods I had been familiar with in the Rensselaer Institute, but carried out with the ampler facilities furnished by government, but essentially the same in conception, in fitness, and certainty of result. On the other hand, when Horsford arrives in Gießen, in his letters home from that period, you can see him kind of clearly saying, I know nothing of chemistry, right? You know, he's been teaching chemistry, he's been doing experiments in front of the classroom, but when he gets here, he's like, yeah, I really didn't know anything until I arrived and started studying with Liebig. Because in Liebig, he finds this very new systematic approach to complete courses, and there's a very intentional development. There's instructors for a whole different variety of laboratory approaches in chemistry, in particular, sort of new research types that they're carrying out. And so it's a very systematic, sort of holistic research study lab in a way that Rensselaer was clearly not. And so Horsford, he studies at Liebig's lab. It's transformative, right, for him. And it's a very strong experience, especially being overseas. And he learns a ton of chemistry. He does a ton of chemistry in the 2 years that he's there. And then he actually is able to come home, and people sort of promote him for this position, the Rumsford professorship at Harvard. And it's expressly because, having been over in Liebig's laboratory and also having published a number of accounts in the US papers about what he's seeing and learning and witnessing over in Europe, he's seen as a very good person to bring that back to the United States and begin to attempt to establish something a little bit like that at Harvard. This becomes tied up with the founding of the new Lawrence Scientific School, partly because Horsford is really emphasizing that what he wants to develop is a practical research training laboratory in chemistry. He doesn't want to be teaching all the sciences and everything under the sun. He wants to focus on chemistry and its applications. What you can see, and this is in 1847, that this sort of happens and develops. And he regularly has students. He has plenty of chemical work, sometimes too much chemical work. And so you kind of wonder, well, why does this not become one of those exemplars of the lab class? It's something that influences them because later people like Charles Eliot actually study and work with Horsford and are definitely familiar with that laboratory. But Charles Eliot, like I said, having been familiar with that, gives us a glimpse into some of the challenges that such laboratories were facing before the 1860s and 1870s, where they begin to take off. And so in 1869, Eliot is writing about these and says that there's this real disadvantage in that the scientific schools are often connected in some way with the established colleges. And the established colleges have this, that people are sending their children there because they want them to have this, refined classical education in high degree. And there's a way in which that is can be complementary to the, the scientific degree, but it's not always in a very clear fashion. And so he says that there's the foundling has suffered by comparison with the children of the house. Even when there have been no jealousies about money or influence, the faculty and students of the scientific school have felt themselves in an inferior position to the college as regards property, numbers, and the confidence of the community, which I think is a very big piece of this. They have been in a defensive attitude. It is the story of the ugly duckling. So that is where, with Eliot and people like him, that we're going to sort of leave off in terms of that's where the new pushes and the new development of the laboratory class sort of emerges out of. What you clearly see is that there were these earlier efforts at teaching through laboratories and through experimentation in the United States. And as part of that, I want to point out that laboratory teaching and learning, I think in the United States and elsewhere, always predates formal laboratory coursework, because there's a long history of private opportunities for instruction and self-study. And in the American context, they often are institutionally supported. The experiment is always a part of education in those approaches. And that role is very clear. What changes historically is how exactly you formalize that role for the experiment in education. And then finally, sort of a basic point, if you walk away with nothing else, is that education and science strongly influence each other. They have common practitioners, they have shared purposes. You find that changes in one can drive changes in the other. And you find that the educational ideals of scientists, of institutions, and of the public really can influence the way science is being done, and in the way it's being taught and presented to the next generation as they're learning what science is and how it really should function.
Thanks so much, Sarah, for that overview of the history of laboratory instruction going back to very earliest parts of the 19th century, actually. A lot of actors there that I haven't encountered myself before. We have time for a few questions. Let me ask a question on behalf of Jane Gale. She would like to know if there is interaction among the first chemical laboratory instructors at different universities. So during the period being discussed, John Emmett, she says, was teaching chemistry at the University of Virginia in labs that Jefferson had petitioned the Board of Visitors to provide.
Yeah, I mean, there's some. And a lot of it, I think, is mediated by things like visits, share, they will often take trips. And there's a lot of correspondence, actually, that goes between people in different places. And some of that is actually regarding things like equipment. right? So there's a few places in the United States that are better at producing scientific equipment, or at least they have facilities and people have more background in producing certain equipment. And so a lot of what you see with someone like Silliman, a lot of his correspondence will be people writing him and saying, hey, I need this piece of equipment, you know, and either they're going to come to Yale or go to Boston or Philadelphia and asking for recommendations as how to do that. But so they are communicating, they are aware of each other. I haven't looked as much into the University of Virginia case, but that would be another interesting one to look at.
Yeah, well, a couple of people were raising a question about that specific case and just wondered if you knew about the recent research on the teaching lab that Jefferson sponsored there, the remains of which are now visible in the basement of the Rotondo. So I'm told that there's been a recently discovered chemical hearth. Is this something you're aware of?
Yeah, I'm aware of it. I haven't seen maybe some of the latest research on it, but this is actually what I've noticed in some of this work is that I think in the American situation, so in the European situation, from what I understand, part of what happens is that early on, a lot of the people involved have private laboratories. Or they have maybe a separate institutional laboratory that's not affiliated with an educational institution. And so it's those laboratories where they're often doing the work. In the American case, a lot of these professors are a little bit more itinerant, or they're coming in briefly, or they're young professors that don't really have the money or the place to do these experiments on their own. And so I think there are reasons that in the American case, you see some of these laboratories being built and constructed in the institution, in the educational institutions themselves, earlier than you may see in some other places. It's a thought. I'm not entirely sure if I'm 100% convinced of it yet, but that's what I've wondered about it, is part of what's going on at University of Virginia. And it's also part of, like, Indiana University, for instance. The first laboratory building is petitioned for in 1838 and constructed by 1840, which seems pretty early for a laboratory building at a university, but I think is actually, in the American tradition, I don't think is that out of place.
This is Mary Ellen Bowden speaking. I think you should investigate the Virginia case, and considerable research has been done on that and is held in a document held by the historical office at UVA, where they go into extensive correspondence and that sort of thing. It gives you a more southern, a more national aspect to your story, if nothing else.
Yeah. Yeah, the southern teaching is actually quite interesting. I mean, Virginia is not as far south as some of the more interesting things, but I've noticed in some of the correspondence with Silliman as well, there's some interesting, and actually even with Horsford, there's some interesting correspondence from people who are teaching and working at further south institutions and talking about that as well.
You know Mary Ellen, don't you, Sarah? That's one of our senior research
fellows. Yeah, last summer, a little bit.
I had a question for you about how laboratory instruction spread to other sciences. It's really interesting because the standard historiography, which I think is pretty much spot on, is that laboratory instruction in a systematic way happened in chemistry first. And of course, you mentioned Liebig's famous laboratory in Gießen. And the kind of people that I studied in Britain, in their CVs, you would always find them having gone over to the continent to gain instruction in chemistry, whether it's at Heidelberg with Bunsen or Königsberg with Friedrich Kohlrausch or any of the famous German chemistry professors, that these British people who would later go on to give experimental courses in physics or natural philosophy in the second half of the 19th century, that tends to be the standard route that they would have pursued. And I wondered whether something like that was happening in the United States with Rensselaer, where professors or people who are going to go on to give instruction in other sciences have gone there and studied particularly chemical experiments, and then have gone elsewhere and set up forms of experiment in the other sciences. Is that the case?
I'm not sure it's so much the case at Rensselaer, but it's definitely the case at, I think, in both Horsford's work at Harvard and Lawrence Scientific School, and also at Yale with Benjamin Silliman, and then his son Benjamin Silliman Jr., who's kind of the next generation of that. You do, like I said, it becomes this interesting sort of two-tier thing, though, where if you're going to start teaching science or doing science, you go to Yale or you go to Harvard, maybe you go to Rensselaer, and it's driven a little bit on sort of some aspects of prestige, but there's also kind of a funding aspect, right? Because if you really have the funding, you maybe go there, but then you also go over to Europe, right? Because the European places have, I think, a higher prestige level than the American facilities do. So you'll find a lot of them, and some historians have noted that a lot of them don't spend really that much time in Europe, right? They go and they conduct an experiment in one of these famous laboratories, but like a few of them have these like longer periods of study over there, but like Horsford for 2 years. But there's others that, they really just go and they sort of briefly tour around and visit these different places, learn maybe a few particular experimental techniques, but certainly some of them are not there long enough for it to be the main formative part of their educational career. And that's where I think this sort of two-tiered, you go to one of the places in the United States that's sort of significant for it, and then you go to Europe if you've got the funding and the support and the time from your institution in order to be able to do that. Does that kind of make sense?
No, that sounds very plausible to me. I mean, I know you mentioned Roland. I know that he was known to the Parisians, for example, and Michelson, I think, spent some time in Europe. But would you say that one of the revisionist or original aspects of your work is in trying to demonstrate the way in which laboratory instruction had homegrown roots in the United States, as opposed to this idea that it was imported from Europe?
Yeah, I think that's part of it, right? Because they are importing something from Europe, right? Mm-hmm. But I think there's also a way in which I think some of them sell the European angle a little bit more. I think there's a prestige aspect to why you go to Europe and what you do in Europe, right? That I think becomes part of this narrative in interesting ways in the later part of the century, where they don't talk quite as much about what they learned and how they studied in the American cases. And some of them, a lot of the earliest ones, do acknowledge these earlier places. But after a little while, that's completely sort of written out of the equation. They don't talk about the scientific schools, or if they do, they universally talk about them as having been these sort of failed experiments. And they ignore the fact that all of these innovators trained in those scientific schools. Mm-hmm. In most cases, most of them had some sort of connection or trained in one of those places and then go to Europe.
Mm-hmm. That's really interesting. I look forward to having more conversations with you about this in the future. So can we thank Sarah? We'll give you a virtual round of applause, Sarah, because it's kind of difficult to figure out how to do that with this new format. But this is also a very good point to end, because next week we're going to expand upon the ways in which the modernization of America was indebted to Europe, in particular the appropriation of German science and technology post-World War II. That's with Douglas O'Regan, a historian of science, technology, and business based in Cambridge, Mass. So I hope many of you will join us then for that talk next week. Sarah, thanks again. Have a great week, and I'll touch base with you soon.
All right, thank you.
Bye-bye.
Well.